Good morning again, dear student. Today, in continuation of satellite, artificial or natural satellite, I am telling to you about the orbital velocity. See, this is the surface of Earth at which it is having radius r. Suppose I want to launch a satellite up to height h from the surface of Earth. So what I have to do, I have to give it the vertical velocity from here, and then I have to provide it orbital velocity, that is called horizontal velocity. So what is orbital velocity? The velocity required to put the satellite into the orbit around the Earth is called orbital velocity. Understood? So due to this orbital velocity only, the satellite is experiencing what? Centripetal force. But according to the gravitational law of gravitation, suppose a satellite is here which is having mass m. This is the Earth which is having mass me, capital M. Distance is re plus h. So what should be the gravitational force? G m small m upon r plus h whole square. But since the satellite is doing orbital motion in a fixed orbit, so it must have a centripetal force. So centripetal force of the mv square upon r, r is equal to r plus h. So this gravitational force is providing what? Centripetal force. That's why both must be equal. Both must be equal. So on equating them, this will get simplified. So orbital velocity is gm upon r plus h. So this is called orbital velocity at height h. But if g is the acceleration due to gravity on the surface of Earth, so you know g is equal to gm upon r square. So what is gm is equal to gr square. So in place of this I can write gr square r plus h. So it will become r into g upon r plus h. So this is orbital velocity. Suppose when the satellites revolve close to the surface of Earth, it means h is very small in comparison to r. So orbital velocity will become under root of gr. Substituting the value of g as well as r, so I can find out orbital velocity of nearby satellite is 7.92 kilometer per second. So this is all about the orbital velocity and the relationship between orbital velocity and escape velocity. You know, escape velocity near to the surface of Earth is under root 2 gre. Orbital velocity near to the surface of Earth is under root gre. So it will become, dividing them, so that will become under root 2 times. So escape velocity is equal to under root 2 times of orbital velocity. This is the relationship. So this is all about orbital and escape velocity. Thank you and have a great day.